Everyone, let's read through the problem once. If angular acceleration of the uniform disk just after release from rest position shown in figure is 8 pi g upon capital N into r, where r is the radius, then calculate the value of capital N. C is the center of the semicircular disk. Usually we take C for center of mass and O for the center of the disk, but here it is clearly given that C is the center of the semicircular disk. Also, you can take pi square as equal to 10. So we have the diagram. Let's draw the forces that are acting. The center of mass of the disk will lie somewhere here inside the material of the disk, and this distance we know for a semicircular disk it is 4r upon 3 pi, and the weight of the body will be acting through this point. So let us call this point as C prime. So C prime is the center of mass of the disk and C is the center of the disk. Now the normal reaction will be offered by the ground like this, and this normal reaction will be passing through the point C. So we can apply torque equation about the point C. We can also apply the torque equation about this point of contact also, but then we have to use parallel axis theorem. You calculate the moment of inertia about C prime, which will not be that easy. You can calculate, but it will involve some calculation. So simplest way to solve this would be to take the torque about the point C. Mg will be acting like this. So if I take the torque about the point C and equate it to I alpha, the torque can be written as mg times the perpendicular distance from C will be 4r by 3 pi, and this should be equal to moment of inertia about the point C. We know it will be simply mr square by 2, just like a circular disk, mr square by 2, and into alpha. So m gets cancelled, one r will get cancelled, and so we have r alpha by 2 equal to 4g by 3 pi, and from here we get the value of alpha as 8g and upon 3 pi r, and if we compare it by 8 pi g by nr, we have 8g in the numerator, so we should multiply by pi. So alpha we can write as 8 pi g. We are multiply by pi in the numerator and denominator so that we can compare, upon 3 times pi square into r, and this pi square can be taken as 10 as it is given in the question. So 8 pi g upon 30r, and if you compare it you get the value of n as 30. So this is the answer. You could have taken the torque about this point also, call this point as O, but then you should have gone by parallel axis theorem to calculate the moment of inertia. You shift the moment of inertia from C to C prime and then apply parallel axis theorem between C prime and O. So it will certainly involve more calculation than what we have done. So better if we take the torque about the point C. So that's it. Thank you very much.